Right, so in this module 11, okay, you will learn about the timer. Okay, so this is the what we call the pembahagian for this timer. Okay, we have a few subchapter, which is first, okay, you will learn about the introduction of the timer. Okay, so there are a few register that you need to know in order to write a timer programming. Okay, and then after that, after you learn about the register that is used for the timer programming, then after that we'll start with a programming timer. Okay, so for the timer we have 3 timers, okay, which is a timer 0, timer 1, timer 2. Okay, timer 0 and 2, this 2 timer is a 8-bit timer, while timer 1 it is a 16-bit timer. Okay, later we will see why this is 8-bit timer and why this is a 16-bit timer. Okay, which one is which timer is what we call here, which timer is more advantage from one to another. Okay, later we will see more details on this timer 0, 1 and 2, and after that, okay, you will learn, you can use the timer to count an event, which is you can use it as a counter. Okay, later we'll see on this part as well. Okay, so let's look at this introduction of the timer. Okay, so in microprocessor, okay, it's very big. I need to resize first. Okay, so in microprocessor, okay, we use a counter register in order to count an event or to generate a time delay. Okay, so you have one count register called a counter register. Okay, so what this counter register do? This counter register is used to count a certain event. Okay, for example, like if you press a switch, okay, every time you press a switch, okay, the counter will keep increasing. Okay, that is the increasing of the counting sequence will be done by your counter register. Or, okay, for the time delays, okay, every time your clock is ticking, okay, the counter register will increase. Okay, so that's why this counter register is very important in order in the timer programming. Okay, this counter register we call it as a TCNT. Okay, so for the timer, as I mentioned earlier, okay, you can use this timer programming first to generate a time delays, or the second one to count a certain events. Okay, so the timer can use either to generate a timer time delays or to count an event. Okay, so what happened here is, if you're going to count a certain event, okay, to do a counter, okay, to use it as a counter, what you're going to do is you need to connect the external event source to the clock pin of the register. Okay, so when an event occurs externally, the content of the counter is incremented. Okay, so here, this is your counter register. Okay, and then we have a flag. Okay, what this flag do? So this flag is used to indicate whether the overflow has occurred or the counting has reached a certain threshold or a certain marks. Okay, so this flag will be raised according to the type of counter that you're going to use. Okay, later we will see more details on this part. Okay, and this counter register, okay, you can connect it to this multiplexer. Okay, which is this is a multiplexer. Okay, it's connected to either to oscillator or to external source. Okay, so if you're going to make this counter register to count an event, what happened here is you need to sambung this clock source here of this counter register to the external source. Okay, how to do that? Okay, since this is a multiplexer, okay, multiplexer, okay, you already learned about the multiplexer. This is a 2-to-1 multiplexer. Okay, you have two inputs. one selectors and one outputs. Okay, so this selector here will determine what is your output based on this input. Okay, for example, the selector now, you put 0 to your selector. So what happens when you put 0 to your selector? The output here is coming from I0. Okay, so output is from I0. So in this case here, if you put 0, the counter register, okay, the input of the counter register is coming from oscillator, okay, which is you're going to generate the time delay in this case. Okay, if you put 1 to your selector, okay, this is your selector kat sini. If you put 1 to your selector, what happens here is the output of which is become the input of this counter register is coming from external source. So now you're going to make this counter register to count a certain event. Okay, so this is the general view of the counter and timer in the microcontrollers. Okay, so if you're going to generate a time delay, so what happens here is you need to connect the oscillator to the clock pin of your counter. Okay, sambungkan you punya oscillator here to the this clock pin of the counter. So now this counter register become, okay, is used to generate the delays. Okay, so every time the oscillator ticking, okay, so oscillator will tick according to the speed, okay, either, okay, if it's 4 megahertz, okay, or 1 megahertz, depending on the speed of the oscillator, and it will keep accordingly. Okay, the content of the counter is incremented. Okay, and then as I mentioned earlier, okay, we have three counter, which is, sorry, we have 3 timers. Okay, timer kosong, timer 1, and timers 2. Okay, timer 0 and timer 2, this is a 8-bit, and this is 8-bit. So the size of this counter register is 8-bit. Okay, so the meaning by 8-bit is refer to the size of the counter register. While timer 1 is a 16-bit, so the size of this counter register for the timer 1 is 60-bit. Okay, means that for 8-bit timer, okay, it can count from 0 to 255 only. Okay, because it is from 00 to FF. Okay, meanwhile, for 60-bit timer, okay, it can count from 0 to 65,535, if not mistaken. Okay, which is from 0 to FF. So means that, okay, timer 1, you can create a larger delay compared to timer 0 and timer 2, because this size of counter register is smaller compared to timer 1. The counter register size is bigger. Okay, and last but not least, here is the content of the counter register represent how many ticks have occurred from the time we have cleared the counter. Okay, so it depends on this counter how many tickings, okay, how many event occurs until the counter is stopped.
Doktor.
Okay, any question? Yeah.
Saya tak jumpa modul 12 dekat e-learning. Ada 10, 11, 13 je.
Kejap ya. Alright, so to generate a time delay, okay, there are 2 methods that you can use. Okay, first is we call it as a overflow method. Okay, and the second one we call it as a CTC or compare mesh. Okay, sometimes we call it as a compare mesh. Okay, so this, okay, terbalik, I terbalik yang ni become the second and this become one. Okay, so let's look at, okay, the first method here call it as a CTC. Okay, so CTC means that clear the counter lah, which is you're going to do a compare mesh. Okay, first, what you're going to do here is every time you're going to generate a delay, so you need to clear your counter register so that your counter register starting at value 0. And then next, what you're going to do is you need to set a certain value level. Okay, when the counter reach the certain level, then what happen here? Now you already produce a delay. Okay, to simply put this way lah. Okay, you have a bottle. Okay, so let's this is a 1 liter bottle, water bottle. Okay, and then okay, you're going to what we call here, put a water inside of this bottle here. Okay, and the flow rate, okay, the water will go to this bottle, let's say lah, okay, 100 milliliter equal to 1 second. Okay, every 100 milliliter, 1 second, every 100, and okay, and then when the level is reached 200 milliliter, now you already produce 2 second delay. Right, so what you're going to do here is for the CTC, which is a compare mesh. Okay, contohlah kamu nak create a 5 second delay. Okay, what you're going to do here is you empty your bottle here. Okay, so that no water inside. And then you put a label which is 500 ml. Okay, so this is a label. This label here, we need to put it to OCR register. Okay, later we will see what is OCR register. Okay, and then you put the water, you pour the water inside here, and the flow rate is 100 millisecond. Okay, so first it will go here. So it already generate 1 second, and then this is 200 ml, another 1 second. Okay, now become 2 seconds, 3, 4, and when it reach 500 milliseconds, so what happened here is, okay, the flag will be raised. Okay, so flag akan naik. Okay, which is in this case the OCF flags will be set 1. Okay, now the CPU know, okay, we already create a 5 second delay. Why? Because the OCR value, okay, which is the level equal to this level of water with our TCNT. Okay, the TCNT is the ni lah, the counter register value. When the TCNT sama dengan OCR value, which is the water level here, equal to the threshold we set earlier. So this flag will be set as 1, and now we already generate a 5 second delay. So this is the delay. Okay, the water level. So this is the delay that you already generate, which is 5 seconds. Okay, for example, a micropin speed is 1 megahertz, and the content of the counter register increment 1 per microsecond. Okay, so the content of the register, the TCNT, the counter register increment 1 per microsecond. Okay, if you are going to generate a delay of 100 microseconds, okay, so what happens is you need to clear the counter and wait it until it becomes hundreds. Okay, so when it reach 100, so now what happen here is you already generate 100 millisecond delays. Okay, so this is for the CTC mode or compare mesh mode. Okay, the second method, we call it as a overflow method. Okay, which is, okay, you're going to load the counter register and wait until the counter overflow and the flag is set. Okay, so dia beza ya. Dia CTC and overflow, the method used for to generate a delay is quite different lah. Okay, so this is the CTC. Okay, for overflow, okay, what you're going to do here is, okay, you have a water bottle. Okay, first, you're going to put a water dahulu. Okay, you need to put a water at a certain level. Okay, inside your bottle here. Okay, and then you put the water here and the delay will started. Okay, until the water overflow from this what we call here, from this water, then what happen here? Okay, now the CPU know that we already create the delay because the water inside of this bottle already overflow, and the flag will be set. What flag that will be set if you use the overflow? We call it as a TOV flag. Okay, TOV flag used for the overflow flag, while OCF flag for the compare mesh. Okay, contoh lah. Okay, we have another contoh here. Okay, a micro P speed is 1 megahertz. Okay, so 1 megahertz, if you calculate the T, okay, the period, T sama dengan 1 over F, okay, sama dengan 1 megahertz, which is you will get 1 microsecond. So your clock will ticking every 1 microsecond. Okay, so with an 8-bit counter register, if you're going to create a delay of 3 microseconds, okay, so what you're going to do is you need to load the counter register with a FD and wait it until the flag is set after the 3 ticks. Okay, for example, the first ticks, okay, the content increase to FE. The second ticks, the content increase to FF, while the third ticks, okay, now you already create a 3 millisecond, 3 microsecond delay. What happened here? It will overflow, which is the content now change from 9FF to 00, and this is when this happen, the flag or the TOV flag will be set. Okay, the CPU know that you already create a delay of 3 microseconds. So this is how the overflow works. Okay, so now, okay, we're going to look at how to do a programming for the timer 0, 1, and 2. Okay, we will go step by step for each of these timer. Okay, first we go to the timer 0, then after that we go to the timer 2, and last but not least is timer 1. How to do a timer programming for timer 1. Right, so let's look at the introduction. Okay, before we go more details on the timer programming, so you need to look at the introduction first so that you can grasp what will happen after this. Okay, so every timer needs a clock pulse to tick. Okay, so as this, what we call here, this figure here, okay, you need to give a clock to this counter register so that it will keep increasing, okay, and it will keep counting. If not, then what happens? Okay, the delay will not be generated. Okay, how to produce a clock here? Okay, so you need to connect it to the oscillator, which is your microprocessor speed, your extra speed, or your crystal frequency speed. Okay, so the clock source, okay, can be internal or external. Okay, so internal clock source, the frequency of oscillator is fed into the timer as the timer delay generation. So you have two clock source here. One is a internal, the second one is external clock source. Okay, while for the external clock source, it will feed pulse through one of the AVR pin as a counter. Okay, so means that if you going to generate a delay, okay, to generate a delay, we are going to use the internal clock source, which is the oscillator speed. Okay, so this is to generate a delay. If you're going to do to count a certain event, to do a counter, okay, you need to use the external clock source. Okay. Okay, so this external clock source can be fed to the microprocessor, okay, to your TCNT using the AVR pins. Okay, later we will see which AVR pins is used as a counter, okay, to as your clock source. So in Omega 32, there are 3 timers. Okay, as I mentioned earlier, we have a timer 0, timer 1, timer 2. Timer 0 and timer 2 is 8-bit, while timer 1 is 16-bit. Okay, so this timer can be used, okay, all of these timer can be used either to generate a delay and to count a certain event. Okay, all of these timer can do this time delay generation and to produce a counter. Okay, so let's look more details on the register. Okay, the basic register of the timers. Okay, so you need to know lah. Okay, what are the register that you need to use every time you're going to generate a delay or every time you're going to make it as a counter. Okay, so in Atmega 32, a total of 4 basic register that are associated with timer. Okay, the first one we call it as a TCNTN. Okay, this N here you can replace with 0 for timer 0, 1 for timer 1, and 2 for timer 2. Okay, so the first register here we call it a timer counter register or TCNT. Okay, and the second register, okay, this is the most important register lah, is TCCR register. Okay, which is a timer counter control register. Okay, so this is where you're going to do the timer settings. Okay, the setting that you can put here is either you're going to use a prescale, and the next one is to choose either it is a CTC mode or overflow mode. Okay, CTC or overflow. All of this setting can be done inside of this TCCR register. Okay, and if you use the CTC mode, okay, there will be one register which is you're going to set the water level, water level that I said earlier. Okay, so this register we call it as a OCR register, which is output compare register. Okay, if you're using an overflow, okay, no need to use this OCR. Okay, and you need to focus on the flags only. Okay, either the overflow has occurred or not. Okay, so this flags here will be stored inside of this TIFR register. Okay, which is this is a flags register lah. Inside of this register, you can see the TOV flags as well as the OCF flags. Okay, so TOV for the timer overflow, OCF for the output compare flags. Okay, this end here you can replace with 0, 1, 2 according to the timer that you're going to use. Okay, so this is the overview lah, all right, of the register for timer 0, timer 1, timer 2. Okay, timer 0, we see here. Okay, you have, this is your TCNT, TCNT 0. And if you use the compare mesh, okay, so you need to compare TCNT with OCR 0. Okay, if the TCNT value equal to OCR 0, what happens? The OCF flag will be set. Okay, so this is for the CTC mode lah. If not, if you use an overflow mode, what happens here? Okay, the CPU will monitor the TOV flags. Okay, if overflow occurs, okay, which is the value has overflow from FF to 0, 0, and then what happens? TOV0 will be high. Okay, so now the CPU know that the overflow has occurred, and another register we call it as a TCCR register. So this is where you're going to do the setting. Okay, similar to the timer 2, because this is 8-bit. Timer 2 also have a TCNT2, 8-bit TCNT2. If you're using a CTC, you need to compare with OCR2. If TCNT value sama dengan OCR2 value, so what happen here is OCF flag will be high. So this is for CTC mode lah. Okay, if you use a overflow, okay, once the TCNT value, TCNT2 value, okay, overflow from FF to 0, 0, so what happen now? TOV2 become 1. Okay, and this is where you're going to set your timer. Okay, meanwhile, for the timer 1, since timer 1 is a 16-bit, all right, so 16-bit, so TCNT1 kat sini, dia punya size is 16-bit. And dia punya OCR, it has 2 OCR, one OCR 1A and OCR 1B. Okay, you can use either one. Some other you're going to use the IA and IB. So OCR A is 16-bit, and this one is also 16-bit. So the size of this TCNT1, OCR1B, OCR1A, all are 60-bit register. Okay, and when you're going to use the CTC mode, okay, you're going to compare lah the TCNT with your OCR, sama ada OCR1B or OCR1A. For example, if you're going to use the OCR1B to compare with OCR1B, so what happens if this value here equal to TCNT, the OCF1B will be high. Okay, and if you're going to use the OCR1A, so you need to compare lah dengan this OCR1A. Once the TCNT value equal to OCR1A, so the OCF1A will be high. If not, if you're going to use the overflow, okay, so once the TCNT1 value is overflow from FFFF to 00000, so what happens? TOV1 akan equal to 1, means that the overflow occurs. And the timer one setting, okay, you have two register here, which is TCCR1B and TCCR1A to do the setting. All this setting here must be done inside of this 1B and 1A. Later we will see the details on this part here. Okay, any question up until here?
No question.
Okay, so now we're going to look more detail. Okay, what is this TCNT, apa tu OCR, what is OCF and TCCR? Okay, so let's look at this one. Okay, the TCNT register is actually a counter register. Okay, as I mentioned earlier. Okay, TCNT is your counter register. So every time you reset your microcontroller, okay, your TCNT value will reset, which is contains 0. So every time you reset, TCNT also reset. And this TCNT, okay, will increase or will count up with each pass. Okay, you have two clock source tadi. Either it is from the oscillator or it is from your external input clock. Okay, so every time this oscillator ticking, okay, so the TCNT value will increases, okay, will count up. The content of the timer or counter can be accessed by loading a value to TCNT or read its value. Okay, you can read the value of TCNT by using if you're using an assembly language lah, you can use the in instruction or out instruction to access this TCNT value. Okay, so this is for the TCNT register. And then moving on, okay, we have the TCCR register. Okay, so this TCCR register is used for setting mode operation. Okay, as I mentioned, there are three things that you can set here. One is a prescaler, and the second one is the mode of the delay generation. Either it is an overflow mode or CTC mode. Okay, and then we have the TOV and flags, okay, which is this flag here, TOV. Okay, every time you see the TOV, you know that that flag is belong to the overflow method. Okay, when this flag is set, what happened here? The CPU know that the timer already overflow. Okay, the counter register is already overflow from FF to 00 if it is 8-bit or FF to 0000 if it's 16-bit. Okay, and the next we have the OCRN register. Okay, so this OCRN register is used to compare the content of the OCR with the content of the TCNT. So this is the OCR register only used if you use the CTC mode. Okay, whenever the OCR sama dengan TCNT, so happen the OCF flag will be set. Okay, and all of this timer register, okay, the OCR1A, TCCR0, TCNT2 or CCR2, all of these registers here are located inside of the I/O memory. Okay, remember back. Okay, for Atmega 32, okay, you can divide your data memory to 3 sections. One is your GPR. Okay, you have 32 GPR, 64 I/O, and followed by your RAM. So all of these registers here are inside of this I/O memory. Okay. Okay, so now moving on to the next slide. So now we're going to do the timer 0 programming. Okay. So for the timer 0 programming, okay, the counter register, we call it as a TCNT0 register. Okay, so it's a 8-bit. Okay, and since it's a 8-bit, so it can count from 0, 0 to FF, ataupun from 0 to 255, or from 0000 in binary to 111111 in. Okay, so this is the maximum lah. The maximum number to count is from 0 until 111111, which is equivalent to 255 in decimal or FF in hexadecimal. Okay, so every time you're using a timer 0, your TCNT must be TCNT 0. You cannot use a TCNT 1 or you cannot use a TCNT 2. Okay, as your counter register. Okay, that is for the counter register. And then now we are going to look at the TCCR setting. Okay, TCCR 0 register. Okay, which is where this is where you're going to do the setting for your timer. Okay, so the TCCR0 is an 8-bit register, okay, used to control the timer 0. Okay, so this is your TCCR0. Dia pun 8 bit. Okay, so now I'm going to tell you, okay, which bit that you need to remember, okay, or you need to focus. Okay, first is bit 6 and bit 3. Okay, these 2 bit here, this is very important. Okay, so this 2 bit, okay, used to this is to select the mode of the timer. Okay, so either you're going to make it as a normal mode, CTC mode. Okay, so normal mode is actually a overflow lah. Okay, so overflow and CTC. Okay, so we're looking at this bit here, WGM00 and WGM01, which is you can refer to this part here, this table. Okay, and I'm focusing on this 2 only, normal and CTC. Okay, PWM and fast WM, okay, just ignore the part. Okay, we're going to focus on this 2 bit here. Okay, for the normal mode ataupun overflow, okay, so this is a normal ataupun overflow. Okay, the value that you need to put here is 0, 0. Okay, bit 60, bit 30. Now the CPU know that you're going to use the normal mode. Okay, if you put a 0, 1 at this bit, so what happened? Now you're going to use the CTC mode for your timer. Okay, so this two bit, this is very important lah to determine what type of mode that you're going to use. Any question about this here? All right. If no question, then we moving to the next bit. Okay, that you need to know is bit 2 until bit 0. Okay, so this bit here, these 3 bits. Okay, so this 3 bit. Okay, which is in this here. Okay, bit CS02 labeled by CS01 and CS00. So what this bit do? Okay, so we focusing on this part here. Okay, if you put 0000, okay, if you put 0000, so what happened here? No clock source, mean timer stop. Okay, 000, no clock source. So this is your selector tadi lah. Alright, so this is your selector actually. Okay, stop timer. If you put a 001, so this is no prescale. Okay, I assume that you already know what is the prescale. Okay, by doing the apa ni, the activities in microprocessor lab. Okay, which is the okay, you already did this thing here. Okay, to create a delay by using a prescale 1024, for example. Okay, so this is the prescale things. Okay, so no prescale means that okay, your external frequency, okay, you divided with 1 without any prescale. Okay, so this is external. External is actually your F lah. Okay, if your external is 8 MHz, so what happen here? If you're using no prescale, so your F sama dengan 8 MHz bahagi 1. Okay, so this is no prescale. Okay, if you put 010, okay, so this is a prescale 8. Okay, what is the meaning by prescale 8? So now what happened here is your F you divided by 8. So now you get the new F which is 1 megahertz. Okay, so that is meaning by prescale. Okay, which is you decrease your frequency. Okay, what happens when you decrease your frequency? When you decrease your frequency, okay, we know that T sama dengan 1 over F. Okay, when you decrease your F, T will increases. Okay, if F is bigger, T will smaller. Okay, so that's why in order to generate a larger delay, okay, we need to make sure that the F is smaller. Yeah, so that we can generate a large delay. Okay, because the delay, okay, the delay equation is delays equal to T period multiply with count. Okay, what is this count? This count here is actually the TCNT value. Okay, later we will see on this part how to do the calculation by using the formula. Okay, and then when you put 011, okay, so 011 means that this is with a 64 prescale. Okay, you divided your frequency by 64 and it will become smaller. And 100, this is with a prescale of 256 and 101, this is 1024 prescale. Okay, so this 5 here for the prescale selection. Okay, what about 110 and 111? Okay, this is where, okay, your clock source is coming from your external clock source. This is where you're going to make your timer as a counter. Okay, remember back tadi, our clock source is coming from either oscillator or external source. Okay, for oscillator, which is you put from 000 until 101. So this is the setting. If you're going to make it as a counter, okay, you need to make sure that this selector here is 110 and 111. So the input, the clock input here is coming from this external clock source. Okay, and mana tadi? Okay, so this external clock source, okay, is located at T0 pin. Okay, kat mana pula T0 pin ni? Okay, later we will see. Okay, where is the T0 pin? And if you put a 110, so this is a 110. So this is a falling edge triggered, and 111, this is rising edge triggered. Means that every time rising edge, the TCNT value will increase. If you put a 110, every time the falling edge, the TCNT will increase. Okay, so this is the setting. Okay, so this is the bit lah, the bit that you need to set lah. Okay, bit 6 and 3 for the mode of the timer, while 2, 1, and 0, this is where you're going to select your clock source. Okay, either you're going to make use a prescaler or no prescaler, ataupun you're going to make a counter. Okay, what about these three? Bit 7, 5, and 4. Okay, bit 7, 5, and 4, you just ignore by putting 0 to this bit. Letak je kosong. No problem. Okay, any question up until here? Okay, no question. I assume that there is no question. Okay, then we go to this. Okay, so this is the penerangan lah on this bit here. Okay, so the bit 0, 1, and 2. Okay, which is CS0 to CS00. So this is a timer 0 clock source. Okay, so this bit are used to choose the clock source. Either you're going to select an oscillator ataupun external clock input. Okay, if you put 00, means that you stop your counter. Okay, this is important. Okay, every time you're going to stop your counter, every time you're going to stop your TCNT from increasing, okay, you need to give 0 to your TCCR. Okay, and the value for 001 until 101, so this is where you're going to select your prescale, and 110 or 111, this is where you're going to make your counter, make your timer as a counter, which is the clock source is coming from the external source clock. All right. So let's look at the examples. Okay, how to do a setting for the TCCR0. Okay, you are going to find the value for TCCR0. Okay, which is normal mode, no prescale, and use AVR crystal oscillator for the clock source. Okay, dia dah bagi tahu normal mode, no prescale, and the source is coming from oscillator. So now we're going to configure. Okay, we're going to determine what is the value that we are going to put to this TCCR 0. Okay, for normal mode. Okay, so for the mode setting, okay, you need to look at this bit here, bit 6 and bit 3. Okay, so what would be the value that you're going to put in order to make it as a normal mode? So you need to put 0, 0 to this bit. Okay, according to this table here, right? Put 0, 0 for the normal mode, while 0, 1 for the CTC mode. Okay, and then tadi dia kata lagi no prescale. Okay, so the prescale things, okay, we need to focus on these 3 bits here, the last 3 bit, bit 0, 1, 2. Okay, what will be the value here? Okay, the value here is 0, 0, 1 for the no prescale. Okay, so this bit here for the prescaling things. Okay, so you put 0, 0, 1. What about the rest? The rest you just put 0, 0. So how to write in the C programming? Okay, you can simply put TCCR kosong equal to 0B 0, 0, 0, 0, 0, 0, 0, 1. So you know that this one is a normal mode or overflow mode, okay, and no prescale. Or, okay, tak mau guna binary, you can write TCCR0 equal to 0x0, 1. Similar. Okay. Or if you don't want to use the hexadecimal, okay, you can use the decimal number, which is TCCR0 sama dengan 1. Pun sama. Okay, so this is how you're going to write a program, okay, to make your TCC timer 0 as a normal mode, no pre-scale. Okay, so let's look at the example number 9.2. Okay, find the timer clock frequency and its period for various AVR-based systems with the following crystal frequency. Assume that no prescale is used. Okay, so no prescale is used means that we no need to divide it. Okay, we just divide the frequency by 1. Okay, so here A, 10 megahertz. Okay, so what would be the clock frequency? The timer clock frequency is 10 megahertz as well, because we divided 10 megahertz divided by 1, you will get 10 megahertz. What about the period? Okay, T sama dengan 1 over F. Okay, the F is 10, so 1 over 10 megahertz, you will get 0.1 microsecond. Okay, so this is for the 10 megahertz external or crystal frequency. What about if you have the crystal frequency of 8 megahertz? So what are you going to do? Okay, so no prescale, so 8 divided by 1, you get the 8 megahertz. Okay, so the clock frequency is 8 megahertz. What about the T? T equal to 1 over 8 megahertz, so you will get 0.125 microsecond or 125 millisecond. Okay, and if you have a 1 megahertz crystal frequency, so the frequency is clock frequency is 1 megahertz, and your period is 1 over 1 megahertz, you will get 1 microsecond. Okay, so this is very important lah. Okay, this formula T equal to 1 over F. Okay, so this is for the TCCR 0 register. Okay, let's lah. Okay, this example here. Okay, now I don't want to use the normal mode, but I'm going to use the CTC mode. Okay, with a prescaler of 1024. So what will be my setting inside my TCCR 0? Okay, so what are you going to do? Okay, for the mode, we're going to focus on this bit here, bit 6 and bit 3. So what will be the value for the CTC? 0, 1. Okay, for the CTC is 0, 1. What about 1024 prescale? For 1024, the value will be 1, 1, 0. Is it correct? 110? No, not 110. Okay, 101.
101.
Okay, 101, not 110. Okay, 101. Okay, so now the rest you just put 0 lah. So TCCR 0, okay, equal to 0B0000 and 110 1. So this is the value. Okay, now what happened here is timer 0 using a CTC mode with a prescale of 1024. Okay, just like that. Okay, so that is for the timer setting. Okay, and then moving on to the TIF register. Okay, so this inside of this TIFR register, this is where your flag register either for the overflow ataupun untuk CTC mode will be located. Alright, so the TIFR stand for Timer Counter Interrupt Flag Register, contains the flag of different timer. Okay, so this is the flag TOV0. So this is an overflow mode for timer 0, OCF0. So this is CTC mode for timer 0. And if you see the TOV1, OCF1B, OCF1A, so this is for timer 1 flags. Okay, TOV1 for overflow and OCF for CTC mode. While TOV2 and OCF2, so this is for timer 2 flags. Okay, TOV for overflow, timer 2, and OCF for overflow. CTC mode timer 2. Okay, so again, dibagi tahu kat sini. So for the timer 0 overflow, okay, the flag will be set whenever the counter overflow, which is going from FF to 0, 0. Okay, because your counter register will keep increase. Okay, and after it reach the FF, okay, when it increase once more, now it become 0, 0. So this is where the TOV will be set. Okay, so when the time roll over from FF to 0, 0, the TOV 0 flag will be set and it remains set until the software clears it. Okay, for the overflow, in order to clear the timer, the flags, okay, you need to do a programming, okay, a coding, so that you can reset this TOV 0 flag. Okay, it will not done automatically. Okay, you need to do it manually. Okay, so this is the difference, okay, between the normal mode or overflow mode and with the CTC mode. Okay, so now we're going to focus how to write a program for the normal mode, okay, or overflow mode. So now we started with the programming. Okay, so in the normal mode, okay, the content of the timer counter increment with each clock. So every time your oscillator ticking, the TCNT value will keep increasing. Okay, so it will count up until it reach its max of FFF. Why FFF? Because timer 0, 8-bit. Okay, so when it's roll over from FF to 0, 0, okay, it will set high the TOV0 flat. Okay, so this is your TCNT value and this is your time. Okay, your TCNT value will keep increasing, right? And then after it goes reach the FF, then when it is roll over here, so what happened here? Automatically TOV sama dengan 1. Okay, when you reset back, then after that it will start it again. If you not reset, then it will not start it. All right. So this is the step taken in order to do to write a program in for timer 0 normal mode. Okay, so just follow this step. Inshallah, you can answer all type of the timer programming. Okay, the first step in normal. Okay, step number 1. The first step, what are you going to do? Okay, first you need to load TCNT value. Okay, how to load a TCNT value? Okay, you need to do a calculation. Okay, later I will give you the okay, tak apalah, I give now. Okay, so the equation, okay, that you're going to need in order to load the TCNT is first you need to have a T equal to 1 over F. Okay, so this is the first equation. Okay, you need to find out what is your period. Okay, and then the second equation is delay equal to T multiply with count. Okay, now you already have the delay. Now you're going to find out what is your count. Okay, which is a count equal to delay over T lah. And the third one is because we're using a normal mode. Normal mode and CTC. Okay, the TCNT value is quite different. Okay, for the normal mode, the TCNT equal to FF. Okay, why FF? Because it is 8-bit. Okay, minus with count, tolak count, plus 1. So this is the formula. Okay, so now after the second step, you already get the count. So now you will get what is the TCNT value. Okay, based on the third equation. Okay, once you load the TCNT, okay, the second step, what are you going to do? Okay, the second step is set the TCCR register. Okay, how to set the TCCR register? Okay, kena refer back to your TCCR lah. Okay, so this is your TCCR. Okay, first thing first. Okay, you need to set this bit here. 1, 2, 3, 4, 5, 6, 7, 8. Right. Okay, so this color, the blue color here is to determine the mode here. Okay, so if you put 0, 0 means that is a normal mode. Okay, put 0, 0 normal mode, 0, 1 TCT. Okay, CTC. Okay, then this 3 bit here, okay, this is where you're going to put your prescale. Okay, the clock source and prescale. Okay, so this is a step number 2 lah. Okay, set your mode and then the prescale. Okay, step number 3. Okay, so what you're going to do is you need to monitor the TOV. Okay, how to monitor the TOV? Okay, the TOV 0 lah, because this is we are using the timer 0. Okay, so monitor your TOV 0. Okay, you're going to check whether the TOV 0 is already raised or is already set or not. Okay, how to do that? Okay, you can use a while loop to monitor the TOV 0. And then step number 4. Okay, once the TOV 0 equal to 1, okay, so what happen here is when the TOV 0 sama dengan 1, so we exit from this loop and stop timer. How to stop timer? Okay, to stop timer, we need to stop under this TCCR 0. Okay, because if you remember back, okay, in this clock setting, okay, if you put a 0, 0, 0, what happened here is no clock source, means that the timer or counter is stopped. This is where you're going to stop the timer by putting 0, 0, 0, 0 to your TCCR. Okay, so to stop timer, simply write TCNT0 equal to 0. This is works every time. Okay, stop timer, just put this coding here. Okay, to do a monitor TOV, okay, there is another coding. Okay, later I will show you the coding. Okay, and step number 5. Okay, what would be the step number 5? Okay, clear TOV 0. Okay, because the TOV 0 currently equal to 1, so you need to clear it so that it becomes 0, so that you can monitor the TOV once more. Okay, how to clear the TOV 0? Okay, so this is a special case. Yeah? To clear the TOV 0, okay, you need to give 1. Okay, every time you're going to clear a flag inside of your register, you need to give 1 so that it will be clear. Jangan give 0. So this is a special case. Okay, for the flags. Okay, you just simply write TOV0 sama dengan 0B. Okay, 0, 0, 0, 0, 0, 0, 0, 1. Okay, put 1 to your TOV0. Kenapa saya letak 1 kat sini? Sebab by looking at the not TOV0 salah. Okay, tebak silap sini. TIFR. Okay, because TOV0 is inside TIFR. Okay, why I put 1 at this location, bit 0, because inside of the TIFR, when you look back at TOV0 is at this bit 0. So that's why we need to put 1 to this bit. Okay, the rest of the bit you just put 0 lah. Okay, because you are not interested with other flags. Okay, so you put 1 here, so you already clear your TOV0. And step number 6, okay, go back to step number 1. Okay, so go back to this step number 1 and it will keep repeating. Okay, doing the same delay. Okay, so this is the step taken in order to do the timer 0 programming. Okay, so you need to remember this step lah. Okay, if you remember this step, then I'm sure that you can answer all of the timer. Even though it's a timer 0 or timer 1, it is the same thing. Okay, so just remember this step. Okay, so this is for the normal mode. Okay, so let's look at this example. Okay, kita tengok example ya, satu example dahulu. Okay, so in the following program, okay, we are creating a square wave of 50% duty cycle, okay, with equal portion high and low on port B, pin number 5 bit. Alright, so timer 0 is used to generate the time delay. Okay, you're going to analyze the problem. Okay, so first, we draw the Omega 32. And then you have a PB5. Okay, so this PB5 here will produce a square wave. Okay, which is this square wave here have an equal high and low. So this is the T lah. T of the square wave. Alright. Okay, so timer 0 is used to generate the time delay. Okay, so the time delay is actually, okay, the delay that you're going to generate is this delay here. Okay, the delay here to produce a logic 1 and to produce a logic 0. Okay, to make a square wave. Okay, so you have a delay, okay, because it says that it has a 50% duty cycle, means that this delay for the logic 1 and the logic 0 equal lah. Okay, use the same delay because the duty cycle is 50%, means that 50% for the logic high and another 50% for logic low. So use the same delay. So this delay here is used to generate this logic 1, and then after it's finished, then after that it will generate this logic 0. Okay, so according to this one, this what we call here information here, okay, you can assume that PB5 you make it as a output point. Why output point? Because you produce the square wave. Okay, this square wave here, okay, using a timer 0 to generate this delay. To generate this delay, which is produce a square wave. Okay, means that nanti when you write down your program, okay, dekat PB5, okay, when you send a value to your PB5, so mula-mula you send 1 to your PB5, so next you call a delay, and then PB5, when it produce a logic 0, and then you call another delay. So this is what happened lah. All right. So now we are going to analyze this program. Okay. So started from the first line here, include avr.io.h. Okay. So this is the standard lah. Okay. And then void to delay. Okay. So here, this is where you going to initialize the delay function. Subroutine. Okay, to delay. Okay, so to delay, because you're going to create a to delay subroutine here, make sure that you initialize at the top here. Ataupun if you don't want to initialize this one here, you can put void to delay on top of this here before your main program. Also can. Okay, if you're going to put this delay function or delay subroutine below the main void main program, so you need to initialize it here dahulu, okay, on top of this program. If not, this subroutine will not recognized by the compiler. Okay, so now we go to the main program. Okay, so under this main program, okay, so first, what you're going to do, you need to make sure lah this PB5 set as a output point. So how to do that? Okay, by using the DDRB equal to, okay, shift 1 to the, okay, shift this number to the left how many times? 5 times. Okay, which is this one here, equivalent is you write DDRB sama dengan 0B001000. Okay, so PB5 you make it as a output port, while the rest of the port become input ports. Okay, and port B sama dengan 0. Why port B sama dengan 0? Because you're going to start it with logic 0 there. Okay, so under while loop, okay, while one, okay, because you're going to do it continuously, okay, you see here, port B equal to port B, okay, what this symbol do? Who going to help me? What this symbol do? Siapa nak tolong? Anyone? Before I pointing a names here. Ada chat je, tak nampak lah kamu punya chat. Okay, what that symbol do? Okay, so this one here, all right. This symbol is known as do the what we call logical exclusive OR. Okay, this is an exclusive OR symbol. Okay, XOR. Okay, means that every time you're going to do a toggle, okay, you can use this exclusive OR, okay, to make a toggle bit, the bits toggle. All right, so what happened here? Port B equal to port B, okay, the current port B is 0 lah. And then you're going to do an exclusive OR with this value, okay, shift 1 to the left 5 times, okay, which is equivalent to, okay, the current value of port B is 0, 0, 0, 0. Okay, because you initialize your port B sama dengan this value, and then you're going to do the exclusive OR with this bit here. Okay, 0, 0, 1, 0, 0, 0, 0. Do the exclusive OR. What happened here is for the exclusive OR, A, B, F, 0, 0. Okay, it will produce 0, 0, 1, 1, 1, 0 is 1, 1, 1 is 0. Okay, so this all of this value will be 0. Set, okay, now your port B become this value. Okay, after this port B become this value, what happened here? You call a delay. Okay, so now you call a delay. So this delay, contohlah, if this delay is 10 seconds, okay, it will create logic 1 10 seconds. Okay, after finish, then it will go back this while loop port B. Okay, you exclusive OR with this value. So what happened? All right. So now you exclusive OR. Now your port B become PB5 become 0. Okay, then you call another 10-second delay. Right. So 10 seconds. So now you already create a square wave. So this is what happened. Okay. So now, so this is the program inside of this T0 delay. Okay. The first step here, okay, what is the first step? This is the first step. Initialize load your TCNT0 with a value. So the value that you load to TCNT0 is F2. This is the second step actually, okay, which is you do the timer 0 setting. Okay, according to this value here, you know that, okay, saya bawa this here. Okay, this is your TCCR0. Okay, the value is 0, 0, 0, 1. So 0, 0, 0, 0, 0, 0, 0, 1. So you know that, okay, so this is a overflow mode. Okay, normal mode. And this is prescale 001, which is no prescale. Okay, so you know that timer 0 normal mode with no prescale based on this this line 2 here, okay, under the subroutine 2 delay. Okay, and the next third step, what is the third step? Okay, this is the third step. Okay, by you using the while loop, okay, you're going to check whether your TIFR, okay, dekat TOV equal to 1 or not. If it is equal to 0, so what happens? It will keep repeating. If not, if this bit here is 1, so this condition is false, then after that, you need to do the step number 4, which is stop the timer. How to stop the timer? By putting a TCCR0 sama dengan kosong. Okay, so this is where you stop the timer. And this is step number 5, okay, which is you clear your TOV flag by putting 1 to your bit TOV0 inside of your TIFR. And then you close the curly bracket, so you are repeating this thing here over and over. So this is closing curly bracket is your actually step number 6. Okay, so in the above program, okay, notice the following step. Okay, mula-mula what happened here? TCNT0 is loaded with F2. Okay, you put F2 to your TCN0, and then set your TCCR0, okay, with this value, okay, which is a normal mode, no prescale. Okay, and then after you set this TCCR0, so what happened here? The count started. Okay, after the line number 2, the count has started. Okay, the TCNT will increase. Okay, so the timer 0 count up with a passing of each clock, which is provided by the crystal oscillator. Okay, as the timer count up, it goes through this state here, which is F3, F4, F5, F6, F7, and this while loop here will keep monitoring the TOV flags. Okay, so F2 the TOV is kosong lagi, F3 kosong, F5 TOV still 0, when until FF TOV 0. When this one here is roll over to 0, 0, so now the TOV become 1. So what happened when TOV become 1? So this line here already false. So what happened? You're going to stop the timer by putting this value. Okay, so this is where the step number 4, and then clear the TOV flags. Okay, by giving 1 to TOV0 bit inside of your TIFR. So this is how you're going to do the timer 0 programming normal mode. Any question? Ada soalan tak? Any question from you guys? Okay, if no question, so this is the last slide lah. Okay, so in example 9.3, okay, calculate the amount of time delay generated by the timer. Assume that the X is 8 megahertz. Are you going to do it today or we continue next time, next week for this calculation here? What say you? So now, okay, we are going to calculate what are the amount of time delay generated by the timer. Assume that the X is 8 megahertz. Okay, based on this value here, okay, you're going to find out what is the delay. Okay, given that the X is 8 megahertz. Okay, so mula-mula, the first equation that we have is F equal to 1 over, T equal to 1 over F. Okay, and based on these settings here, there is no prescale use. Okay, no prescale use means that F sama dengan, this is F new ya, F divided with a prescale. Okay, since no prescale means that 8 megahertz divided with 1, so you will get 8 megahertz. Okay, sama dengan 1 divided by 8 megahertz. Okay, what you will get here? Sama dengan, can anyone press the calculator for this example?
0.125.
Okay, 0.125 microseconds ya, betul ya?
Yes.
Okay, so this will be your T. Right, so the second equation, delay sama dengan T multiply by count. You don't know the delay. You have the count, T. T is 0.125 microsecond. What about count? Do you have a count? Yes, you know the count. How you know the count? Because you already have the TCNT value. So now we go to step number 3. We just leave the step number 2. After that, we will resume to, we go back to here. Which is step number 3. Not step number 3 lah. Equation number 3. TCNT sama dengan FF or 255 minus count plus 1. You know the TCNT value, correct? The TCNT is F2. So F2 sama dengan FF minus count plus 1. So now count. What would be your count? Count sama dengan FF minus F2 plus 1. Can somebody press the calculator? Berapa dapat?
Sorry Doktor, apa?
FF.
Oh, ubahan. Cari nilai count. Okay,
Ya, cari nilai count. FF minus F2 plus 1.
Tin.
14 ya?
Yes.
So this is 0E, betul tak? Mula-mula 0E and then you change it to decimal, you will get 14. So now you already get the count. So now we go back to equation number 2. So this is a 14. So now you will get your delay. What would be your delay? 14 darab dengan 0.125 microsecond.
1.75 micro.
1.75 microsecond. So this is the delay generated by these examples here. Any question up until here? Ada soalan tak?